Hi guys, happy Monday. Welcome back. Today we're going to take some notes over multiplying with fractions. So go ahead and get out your journal, a new piece of paper, whatever you are using, and we are going to title this page Multiplying with fractions. And remember, the nice thing about this being video is that if you need to pause it at any point to catch up, go get more supplies, whatever you need, sharpen your pencil, please do so. So multiplying with fractions, we're going to take a quick little note up at the top that we need to keep in mind for when we're multiplying with fractions. So I'm going to do a little star symbol. And though multiplication has a, this is a big word, communicative, oh my gosh, I can never say it, y'all. Communicative property. I'm 90% sure I'm saying it wrong, but that's okay, as long as we spell it wrong. Oh, right, no, spell it right. Okay. Though multiplication has a communicative property, and what that means is that you can flip the factors and still get the same product. So y'all know this. It's like saying 2 times 4 equals 8. Well, guess what? 4 times 2 equals 8 too. Just flipping around the factors doesn't actually change the answer, the product. So though multiplication has a communicative property, you can flip the factors and still get the same product. So even though it has a communicative property, the order of the factors matter when representing. So even though I know that, 4 times 2 equals 8 and 2 times 4 equals 8, the order in which I write them really does matter, because I can have 4 groups of 2, or I can have 2 groups of 4. It's different, and it would look different depending on which numbers come first, which factors come first. So we're going to split our page in a T-chart. Just go ahead and split your page in a T-chart. On one side, we're going to do whole times fraction. And on the other side, we'll do fraction times whole. Because again, even though I can flip them, it is going to matter. It's going to matter which model we actually use to represent both of these problems. We'll start with the whole times fraction. So that means we're going to do a whole number first. Remember, in 5th grade, that's really all we do. We're not going to do fraction times fraction, and we're not going to do like mixed number or anything yet. You will do that more so in 6th and 7th grade, okay? So we just focus on these two types of problems. Whole times fraction, fraction times whole. Let's start here. Let's do 5 times 4, 6. 5 times 4, 6. Okay? So remember, that little multiplication symbol means something. I can say this problem out loud, just like how I did earlier with the 4 times 2. 4 times 2 equals 8 is the same as saying 4 groups of 2 equals 8. So it's the same thing. 5 groups of 4, 6 equals a number. We don't know it yet. So we're just going to write underneath groups of. Okay, because that's what that means. That's in this problem, that multiplication symbol means 5 groups of 4, 6. And I know that's the right one because it just sounds right. It makes sense. I can make 5 groups of 4, 6. We usually match it with a story. So let's provide a little bit of context to our problem, right? Let's add a little bit of a story to it. It'll be Paul Revere. We'll throw a little bit of social studies in there too. Paul Revere rode, that was the wrong spelling of road. Y'all, been home for too long. Rode 4/6 of a mile every day Monday through Friday. How far did he ride in all? Like for the whole week. So Paul Revere's riding his horse saying, the British are coming, the British are coming. He's going to ride every day 4/6 of a mile. Isn't very far, but, you know, maybe his horse is slow. It's old. And he rides Monday 4/6 of a mile, Tuesday 4/6 of a mile, Wednesday 4/6 of a mile, Thursday 4/6 of a mile, and Friday 4/6 of a mile. So we can show that by using a model. The model would include this first, the 5 first. So I'm going to draw the 5 first. I'm going to draw just 5 squares, rectangles, whatever, circles, whatever shape you want, really. I'm going to draw 5 of them. They're all equally sized. And each one represents a what? What is the 5 in this problem? Where did I get 5 from? Right, days of the week. Monday, Tuesday, Wednesday, Thursday, and Friday. Days of the week. So, if each of these days is here, he rode how much each day? 4/6. So I need to color in 4/6 here. And that's the great thing about having maybe some color nearby. So I'm going to make 6 out of each of these boxes. So to do that, I usually make thirds first, like that. I make thirds first, and then I just cut the thirds in half. And that makes 6. So I create thirds, and then I cut them in half. Create thirds. And there we go. Each one is cut into 6. And now in these 6, this is 6, 6, 6, I'm going to color in how much in each? 4 pieces. Yeah. Because he's not riding the whole mile each day. Remember, he's not even riding 1 whole mile each day. He's riding less than a mile each day. So he's riding 4/6 of a mile every day. There's 2/6 of each day of a mile that he's not riding. So you tell me, how many 6 are colored in? How many total pieces, how many 6 are colored in? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, right? 26. 26. Just saying it out loud tells you how to write it. 26. Looks just like that. Obviously, that's called a what? An improper fraction. The numerator is significantly bigger than the denominator. We don't want to leave it like that, so let's fix it. To fix an improper fraction, we see the 6 goes into 20 how many times? Well, I want to get as close as possible. 6, 12, 18, 24, too much, go back. 6, 12, 18. It goes in 3 times, and I was able to get all the way up to 18, so not perfect. 18's how far away from 20? 2, so then that's what's left. 2, 6, that's how much I couldn't get in. And there's your answer. Your answer is 3 wholes and 2 6, or if you wanted to simplify it, it's the same as saying 3 wholes and 1/3, right? 2 6 and 1/3 are equal, because half of 2 is 1, half of 6 is 3. You always want to try to simplify your answer if you can, because you know tests, the STAAR test, interims, they always put the simplified answer there, never your answer. That's why you're like, well, where's my answer? It's there, it's just not in the form you expect. Another method I taught y'all, just while we have the model here, is the borrow and carry method. It's where you start maybe at the end of your model, and you scratch out one of the 6, and you carry it over. Because that's the same size piece as that, right? So can I just borrow from here and fill in here? So the X and carry. Okay. I'm going to keep borrowing from the same piece until this piece is gone. The X and carry. The X and carry. So now I have 2 holes, but I have 2 incomplete pieces, or 2 incomplete holes still. So I'm going to X, carry, X, carry. Okay, there's nothing more to carry, right? Because I have 1, 2, 3 holes, and how much left? 1, 2, 2, 6. 3 holes and 2, 6. Do you see how that model matches that answer? So if you don't like all of this improper fraction business, don't do it. Use the model. Use just the model to achieve your answer. All right, scooch it on over to fraction times whole. So this one, even though, again, you can flip multiplication, it's going to be a little different how we model it because we're going to put the fraction first. We're going to put 2/3 times 24. Now last time we said 5 groups of for 6. But when I say this one out loud that way, it doesn't really make sense. 2/3 groups of 24? How do I have 2/3 groups of? Right? That just bothers me because it doesn't really sound right. So take out the word groups. If you have the fraction first, you're not going to say the word groups. You're only going to say the second word, of. 2/3 of 24. Now that sounds better, right? Because you've heard that before. You've heard things like that before. Hey, do you want half of this pizza, dude? Hey, can I get a 1/4 of that taco? I don't know. You've heard people saying a fraction of something before. Oh, that burger's a 1/4 of a pound of meat. So you've heard this before, this use of. And that happens when the fraction comes first before a whole, in a multiplication times a whole number problem. So we're going to match it with a story. Olaf. Yeah, y'all know I've been watching Frozen 2. It's on Disney+. I also have this pen dispenser. So Olaf, Olaf hopped 2/3 of a 24-mile journey before he melted. Olaf hopped 2/3 of a 24-mile journey before he melted. Tragic. I'm sure you just like rephrase this, though, right? How far did he hop? How far did he hop? He didn't hop all 24 miles, right? He didn't finish the trip, because then it would be 3/3, a whole. So he didn't make it the whole 24 miles. He made it part of the way. And that's what you need to be thinking of when you think of this model. There's a hole. There's a certain hole that you have, and I know some of you are like, oh, wait, I know where she's going, because I've said it like this a million times. You have a hole, and you only have part of the hole. We're not talking about the whole thing. He didn't make it the whole way. He made it part of a hole, part of a way. So you need to start with drawing the hole. And the hole is usually just a large fraction bar. Because that bar can be whatever amount you want it to be. This can be worth 100, this can be worth 1, this can be worth 5. It's up to the problem. In this problem, what was the whole journey? How far? 24 miles. So that's how far this model is going to be worth. This rectangle is worth 24 miles. Okay? That's what the whole rectangle is worth. The whole rectangle is worth 24 miles. I'm going to split it into how many pieces? Look at the problem. How many chunks is it going to be split or divided into? 3. 3 equal-sized chunks. Okay, not so equal, but it's supposed to be equal. Do better than I did. You're going to split it into thirds. Cut into thirds. And now to find out how much each third is worth, well, this is 24 split divided into 3 equal pieces. 24 divided into 3 equal pieces. Wonder what number that is. What's 24 divided by 3? Good, it's 8. So each piece is worth 8 miles. But that's what 1/3 is, but we're not talking about 1/3. This is where so many people mess up. They get this and they go, oh, my answer is 8, I'm done. Yay. Let me go celebrate. And it's like, wait, pause. No, you're not. The problem wasn't asking for 1/3. The problem was asking, drop my pencil. The problem was asking for 2/3. So yeah, if you were trying to get 1/3, 8 would be your answer, but what is 2/3? 2 of the pieces. What is that answer? There you go. 16 miles is 2/3. 16 miles would be equivalent to 2/3 of 24. Because it makes sense. He didn't bike the whole 24, but, you know, he biked more than half. And half is what? Half of 24 would be what? 12. So he biked more than 12, but not the whole thing, and not only 8. All right? That is it for today. Thank you so much for joining me. Hope to see y'all soon. And until next time.